3.4 Applications of Set Theory. Today we're going to focus on what it looks like to shade in different Venn diagrams, and we're also going to, on the second page, deal with a problem using the principle of exclusion and inclusion, but with 3 sets. So far we've only done it with 2, so we're going to see how that formula for the number of elements in the the union of 3 sets works when there are 3 instead of 2. So we learned this last time, but we didn't take down any official notes on it. So the way that we would say this is A not B. So this includes all the elements of A that are not in B. Some of these should look familiar already, so let's just take a moment and do a few problems. So shade in the following. I'm going to get my my highlighters here. So A union B, that means that everything in A is included and everything in B is included. So the solution space for this would be everything that is in A and everything that's in B. Since it's the union, not the intersection, it's not where the two intersect. If we're to focus on this one right here, A intersect B, it's where the two intersect. So the elements that are a part of both A and B. In this one, A union B, it's anything that is a part of A or that's a part of B. With this one, it's just the elements that are the overlap. A not B. So everything that's in A, that doesn't include anything that's in B. So we kind of have this cookie shape here. C is for cookie, that's good enough for me. This one's tricky, so it's the complement of A, so anything that is that's not in A, union anything that's not in B. So the complement of A union the complement of B. So I'm just gonna color in anything that's the complement of A. And now I'm going to color in everything that's the complement of B. So anything that is not in B. So I would recolor all of these guys here, and I would include this one here. Now this is going to be a little bit tricky. Sometimes the solutions for these things, even though I have a different documentation, will look the same. Let's see what I mean. So anything that's the complement of A intersect B. So here's A intersect B. So anything that's not in A intersect B, I'm going to color in. You'll notice that the same solution space is the same, or the same solution space is shaded in for both of these, even though they're expressed differently. So this one right here is everything that's in B except for that intersection. So this is A not A intersect B. Now think about it. Is there any way that we can express this? Is there any way that we can express the shaded in part that's different? We can also say that it's B not A. So everything that's in B, but not anything that's in A. So these two things are, they provide the same solution set.